You're watching DD Science and I welcome you all to your favorite program, A Question of Science. In today's episode, we will introduce you to the exhilarating world of shockwaves and how we can use them for many innovative applications.
It only takes an instant, sometimes less. In this instant, everything changes. In less than a blink of an eye, extreme conditions cause massive alterations to surroundings, be it an explosion, an earthquake, or lightning. Catastrophic events lead to shock waves that hold the potential for immense upheaval. But what if the colossal energy of shock waves could be used for good? That's a question of science. Wherever there are waves, they bring change. With each wave, the status quo is disturbed. Something is released and something is destroyed. In the process, something new is born. Waves are nature's way of redistributing energy. Whether it's a pebble that transfers its potential energy into the ripples of water, or two hands clapping, releasing mechanical energy as sound waves. As waves move through their medium, be it solid, liquid, or gas, they find one way or another to transfer their energy. But there are some waves that just don't have enough time or space to gently pass through a medium. In these situations, how do they release their pent-up energy? The answer is shock waves. Scientists like using a simple experiment to show how they work.
There is certain amount of energy which was stored here by way of high pressure, and if I create a scenario where this energy has to be released within a very short time, then shock waves are one of the most preferred means. I have a balloon, I just use a needle and I puncture it. Now you heard a sound, but suppose if I were to measure this using a small pressure transducer, you will record a signal where the pressure would suddenly go up few times the atmospheric pressure, and because of this wave, all the energy that was stored inside essentially comes out.
As the experiment shows, shock waves occur when there is a sudden release of large amounts of energy in a medium. In doing so, they transform the medium in extreme ways. In an instant, there are drastic changes in pressure, temperature, and density. A Diwali cracker expending its chemical energy. A bolt of lightning dissipating its electrical energy. Or an earthquake spending its mechanical energy. All are examples of dramatic and often violent changes that a shock wave can bring about. That makes shock waves quite different from those other waves we're familiar with. Sound waves.
Sound wave is something which propagates through the medium, and when it propagates, there is no change in the different flow quantities like pressure, temperature, and density. On the contrary, when there is a sudden release of energy which takes place in few microseconds, then there will be formation of shock waves.
And here's the most basic difference between sound and shock waves: their speed. Sound waves travel at about 340 meters per second. Fast as that is, shock waves are even faster. So when an object, like a fighter aeroplane, breaks the sound limit and moves faster than 340 meters per second, it creates shock waves, or waves that cause extreme changes in temperature and pressure just behind it. In fact, shock waves are so rapid that normal measurement units like meters per second or milliseconds just aren't good enough. So how are they measured? Speeds that exceed the speed of sound are measured in Mach numbers. Mach numbers are calculated by dividing the object's speed by the speed of sound. So anything with a Mach number less than 1 is termed subsonic. Most of the vehicles we see on the road fall in this range. Anything with Mach number equal to 1 is termed as transonic and is equivalent to the speed of sound. Most of the airplanes we see in the sky are approaching, although not quite hitting, this speed. Objects with speeds between 1 and 5 Mach number are called supersonic. Some defense aircrafts used by the military are able to reach these speeds successfully. Finally, any object that reaches a Mach number of 5 or more is said to be hypersonic. Some space shuttles manage to achieve hypersonic speeds. But why are Mach numbers important for us to know? As you may have guessed by now, once objects exceed Mach 1 to reach super and hypersonic range, shock waves are created. At this stage, some rather strange things can occur. Deep within the campus of the Indian Institute of Science, Bangalore, is a very special science lab. It looks more like an aircraft hangar or a massive factory shed. But this lab houses some of the leading Indian scientists in shockwave research and hypersonic technologies. This unique group of physicists, chemists, engineers, and aerospace experts studies what happens when shockwaves are born. It's time to break the speed barrier. Supersonic and hypersonic jet vehicles. From defense aircrafts to space vehicles, these marvelous machines reach astounding velocities that most people, like you and I, are completely unfamiliar with. At these velocities, conditions are extreme, and there's one phenomenon that just can't be ignored: shock waves.
Because there is a massive energy dissipation which is involved with such vehicle, shocks are invariably formed around any vehicle which travels at supersonic or hypersonic speed. So as aerospace engineers, for us it's very important for us to know what are the characteristics of the shock wave which is ahead of the vehicle.
Shock waves can have devastating effects on the structure and mechanics of an aircraft. They create an enormous drag or opposing force on the vehicle, slowing it down. They cause drastic changes in temperature and pressure, enough to destroy the hardest metals out of shape. They also affect the chemistry of materials the aircraft is made of, and they do all this in a matter of microseconds. And so, to ensure that such damage does not wreak havoc, the Hypersonics and Shockwave Research Laboratory asks the all-important questions.
The laboratory is equipped with a wide range of test facilities, and after a short break, we will see how they seek answers through their research studies. So please don't go away. We'll be back after this short break. Once an aircraft exceeds its critical Mach number, shock waves form on the wings and stabilizers, and further increase in the speed causes the shock waves to grow and move towards the trailing edges. Well, is that good or bad? Let's find out.
How do shock waves affect airplanes or space vehicles moving at supersonic and hypersonic speeds? What kind of structural, mechanical, and material changes do they undergo? The search for the answers lie in various experiments conducted by creating shockwaves in a safe and controlled manner. When it comes to creating controlled shockwaves, the most remarkable machines are shock tubes and shock tunnels. Inside this completely indigenously built pipe-like structure, speeds as high as Mach number 15 can be reached.
This is called a shock tube. So a shock tube has two sections. One is the driven section, one is the driver section. So you have these two sections divided by a metal diaphragm. This metal, we place it in between the two sections. So when we increase the pressure on one side, which is the driver section, this metal ruptures. When this metal ruptures, you have the diaphragm opening up this way. So this is how a shock wave is generated in this tube, and it propagates downstream, and that is what we use for all our testing purposes.
As the shock wave moves down the tunnel, it approaches the test section of the tube. Here, scientists are waiting to expose different components to the super and hypersonic flows that the shock waves bring. Every component of a super and hypersonic vehicle is tested in facilities like these. The test results give aerospace engineers and designers a chance to build better, stronger, and faster machines that make India self-reliant when it comes to defense, aviation, and space engineering. Even more remarkable than these results is the very fact of how these machines were built. In the nascent days of hypersonic and shockwave research, instruments like shock tunnels were hard to come by. But that didn't deter our scientists. Local small-scale manufacturers stepped in to lend the scientists a hand. In some cases, they even trawled through junkyards to look for scrap materials to build their instruments. The result? A state-of-the-art laboratory that attracts the best minds. One of the few of its kind, not just in India or Asia, but in the world. As scientists at the Hypersonics and Shockwave Research Lab began unraveling the effects of shockwaves on aerospace vehicles, another fundamental question began pulling at them. It was a simple query. Could shockwaves be anything other than damaging? Could their immense and instantaneous potential be harnessed to help mankind? The answer was yes. But nothing could be further from supersonic jets. Injections, needles, syringes. The very idea often puts fear in the eyes of patients. Even if these needles administer life-giving drugs, they still come with a host of problems. They're painful and difficult to dispose of safely, often becoming carriers of deadly infections. But if left up to shockwave technology, needles could be a thing of the past. The secret lies in the idea of micro shockwaves. By scaling down the intensity of a shockwave, using as little energy as a few joules, scientists realized the potential of micro shockwaves. Potential that reached far beyond the field of aerospace engineering. The Molecular and Cell Biology Lab at IISc Bangalore is home to a lab conducting research on vaccine and drug delivery. About 5 years ago, they were introduced to a novel and exciting concept, the micro shockwave device invented at the Laboratory for Hypersonics and Shockwave Research. It was an unlikely collaboration between biologists and aerospace engineers, and it opened up possibilities for a brand new way to administer medical drugs into the body.
The device works in the following manner. Now this is a small power source, and then we have a small plastic tube, and this tube has got a certain tiny amount of chemicals inside. Now when I press the button here, there is a battery inside which essentially charges up, and then the chemical energy is converted into mechanical energy, where there is a blast wave which is generated at the end of this tube.
The device's sudden impact allows medication to penetrate skin at 100 meters per second. The controlled generation of such microshocks also ensures that the drugs go to a specific depth of 100 microns under the skin's epidermal layer. Why is this depth so critical for drug delivery?
For vaccine delivery, the epidermal layer of the skin is very much advantageous for many of the vaccines. But to deliver into that epidermal layer is very difficult because it is only 100 micrometer thickness and the needles cannot be used to deliver in such areas. So, and the presence of antigen presenting cells is high in that region.
These antigen presenting cells are some very useful cells called Langerhans cells. They process antigens in response to the injected vaccine and give the body's immune system the chance to fight disease. With the Shockwave device delivering drugs straight to these cells, immunization or drug treatments become faster and more efficient, using far less dosages than any other delivery method.
The two departments, it was so kind of complementary that we indeed tried our first in-home, inbuilt vaccine candidate, which is against the typhoid, in the mouse model of typhoid fever, which is a very successful model. So we are going to try out not only with the bacterial vaccines, but with the whole range of the vaccines. So whether this system is good enough to, in fact, give the protection to different kind of vaccination, through different kind of vaccination protocols and to different diseases.
Besides drug delivery, it also stretches itself to other biological uses. Futuristic gene guns that can shoot DNA directly into a cell, or using shockwaves to transform cell structure and cell mechanics. In an ironic twist, shockwaves that are notorious for explosive damage can someday become lifesavers.
And when commercialized, this device or technology could replace the dreaded injections used in drug delivery. Well, with this, it's time for a short break. So please don't go away. We'll be right back.
In 1969, Dmitry Mendeleev, a Russian scientist, formulated the periodic law and created a far-sighted version of the periodic table of elements, which not only had the list of 10 discovered elements, but it also left space for the undiscovered elements as well. Year 2019 marks the 150th anniversary since Dmitry Mendeleev came out with the periodic table system, and UNESCO has proclaimed it as the International Year of the Periodic Table of Chemical Elements. There have been numerous modifications in the periodic table since then, and today it is one of the most significant achievements in science. Rather than memorizing facts and figures for each element, a quick glance at the table reveals a lot about the reactivity of an element, whether it is likely to conduct electricity, whether it is hard or soft, and many other characteristics. Once scientists and researchers understand this data, they can apply it in their experiments.
In recent times, utilizing the nearly instantaneous changes in fluid velocity and pressure produced by shock waves, many innovative techniques have been developed or are being developed for medical, biological and other applications.
A single blast of shockwaves can have as many uses as the imagination allows, and a field once associated with aerospace is now touching the lives of rural Indians. Shockwave devices have been used in the extraction of oil from sandalwood, seeds, and grains, drastically cutting down the amount of energy resources and time as compared with conventional methods. It's also proven to be very successful in injecting preservatives into natural products like bamboo.
Bamboo is regarded as a rural gold, and if you can treat them with preservative, then people in the villages will be able to build houses using bamboo. What we have tried here is to use shockwave, like you have a chamber filled with the preservative, and then when the shock basically goes through that, immediately you find that all the preservative which is stored actually goes inside, settles down nicely. Thereby the bamboo is now having resistance to microbial attack whenever it is used outdoor.
Not just rural India, even Indian industry will be the beneficiary of shockwaves in the coming years. From tea production to mining industries, nearly 15 patents filed by this lab will be developed into scaled-up devices. In every way, shockwave technology lies at the very frontiers of futuristic possibility. In fact, it finds itself smack in the middle of one of 21st century's greatest technological races. Imagine a time in the future when you won't just be able to travel at supersonic speeds across the globe, but into outer space. Space tourism and exploration using shockwave technology is not a pipe dream, but a global quest. One of the ways to do this is scramjets. Scramjets, or supersonic combustion ramjets, are being chased by scientists and engineers across the globe, including Russia, USA, Australia, and France. Even India has joined the technological race to develop the most powerful and efficient scramjet engine. But what exactly is it? Scramjets are engines which only operate once an aircraft is taken to supersonic speeds by turbojets or rocket engines. At these incredible speeds, scramjets use supersonic airflow to create combustion of fuel. This creates so much thrust that the craft is propelled to near hypersonic speeds, faster than just about any other engines currently in use.
You are seeing one module of a scramjet supersonic jet engine. Now these engines, modules like this will be mounted at the bottom of a vehicle like this. This is a typical vehicle which is called as a hypersonic vehicle, which can travel at velocities which are of the order of 10,000 kilometers per hour kind of.
This rather modest-looking model of a scramjet packs in a punch. With virtually no moving parts, it's a simple yet highly intricate structure that can drive flight transport vehicles to unimaginably high speeds. So far, no single research team anywhere in the world has been able to create a design that can execute more than a few minutes in flight.
They are going to be critically dependent on the success of supersonic jet engine, namely the scramjet engine, which is fairly complicated animal. So far only the engine has gone up to about 300 seconds. Americans have done a flight test, but nothing is commercially done.
But before this dream can become a reality, there's the challenge of finding the perfect fuel. One that can not only take the craft to hypersonic speeds, but can also withstand the drastic conditions created by shockwaves in hypersonic flight. In India, challenges like these are taken up by the Chemical Kinetics Group of the Hypersonic and Shockwave Technology Lab. Instead of a conventional chemistry lab with beakers and Bunsen burners, this group uses shock tubes and shock tunnels. They're searching for the answer to a basic question: how do different chemicals react in the extreme environment created by shock waves?
The shock waves are compression waves which can increase the pressure and temperature of a gas. When they do, the gas which is stable at room temperature can start reacting. So we let the gases react and then measure the rates at a function of temperature. This gives us very fundamental information about how and why molecules react. But it turns out even our defense and space organizations are interested in this because they use these molecules as fuels to launch the rockets.
Although a viable technology is still a long way from being publicly available, shockwave technologies like scramjets will revolutionize airplane engines and air travel.
5 or 6 countries are pursuing it very rigorously with the ultimate aim of developing a hypersonic cruise system. So if I have an aircraft which can travel at about 10,000 kilometers per hour, I can reach from Bangalore to Delhi in 15 minutes, Tokyo to New York in 2 hours.
Shockwave technology could change the very face of the future, be it medicine, biological research, or cutting-edge industrial applications. From space exploration and intercontinental travel to perhaps even small-scale and cottage industries, shockwaves could make our science fiction dreams come true. So keep an eye out for the innovations they bring. It promises to shock and awe.
And with that, we conclude today's episode. Do send in your feedback to us at ddScience@vigyanprasar.gov.in, or you can write to us at Vigyan Prasar, A50 Institutional Area, Sector 62, Noida, Uttar Pradesh 201309. For program details and schedule, you can always visit our website www.vigyanprasar.gov.in. So, till the next time, goodbye.